All right, so we're going to talk about our third type of special case when I multiply two binomials together. Okay, so notice these look almost the same. So it's almost like I'm squaring it, but one's put together with addition. The other terms are put together with subtraction. Okay, it doesn't matter what the order is in terms of binomial with addition or subtraction, but if it almost looks exactly the same, so if the terms are exactly the same, but one's addition and one's subtraction, then that's a special case. So let's do it the long way and see what happens. 6x times 6x, 36x squared. 6 times negative 1, negative 6x. 1 times 6x, also 6x. And 1 times negative 1 gives me a negative 1. So this is super convenient for us because in the middle, I get the same terms, one's addition, one's subtraction, and so they cancel. So 6x plus 1 times 6x minus 1 gives me 36x squared minus 1. So you might be noticing a pattern. Let's see what happens with this one. 5x times 5x, 25x squared. 5x times 2, positive 10x. Negative 2 times a 5x gives me a negative 10x. And negative 2 times positive 2 gives me a negative 4. So again, my middle terms are the same. One's addition, one's subtraction, so they cancel. So 5x minus 2 times 5x plus 2 equals 25x squared minus 4. So why don't you try the last one and then check back. So pause it and then check back to see if you got the same answer. I'm going to do mine using the box method. So see what happens while you're working on that. I will do this. Okay, so if you're joining us back or you don't want to listen, don't listen. So here's the box method. 3 times 3 is 9. X squared times x squared is x to the power of 4. 3 times 4 is 12. X squared, w squared. So I can't combine exponents because they're different bases. Negative 4 times positive 3 is a negative 12. And then I'm just going to tag along the x squared and w squared because, again, they're not the same base. I cannot combine exponents. Negative 4 times a positive 4 gives me negative 16, w to the power of 4. So I noticed that the diagonals, the like terms, are going to cancel. So I end up with 3x squared plus 4w squared times 3x squared minus 4w squared gives me 9x to the power of 4 minus 16w to the power of 4. So hopefully you notice all of these are put together with subtraction. Okay, the first term is the first term of this squared, and the second term is your second term squared. So let's write that out. So again, A represents your first term, B represents your second term, no matter what it is. It doesn't just have to be a number or a variable, whatever that full term is. So A plus B times A minus B. Let's do that out. So A times A squared, A times B, AB, A times negative B, negative AB, and negative B times B gives me negative B squared. So you'll see the diagonals are my like terms, and they're always going to cancel with each other. So I'm left with A squared minus B squared. And just like the last video, I invite you to go back and double check that this is true. Put in your first term, square it, subtract it with your second term squared, and see what we get. So again, hopefully this works for you. This is called the difference of squares. And we're going to return back to that when we get to factoring. This would be a great thing to save in your notes and refer back to when you're factoring. And also it's a great shortcut to not have to do these by the long way every single time. All right, see you later.